Hello, Algebra 1. We're moving on now to Chapter 4, which is all about graphing linear equations. And I know that you've practiced graphing back in middle school several times, so I'm not going to spend as much time on some of the points that are familiar to you. I don't want to review too much. And for example, I'm going to put Chapter 4.1 and 4.2 together as one video lesson. Later, though, we're going to come to some things that truly are new for you about graphing, and there we're going to really get into it in more detail. But let's start with just combining 4.1 and 4.2. First of all, looking at 4.1. Chapter 4.1 has a lot of vocabulary in it that's probably familiar, but I have to make sure. So, for example, a coordinate plane. Well, that is made by two lines, a horizontal line called the x-axis and a vertical line called the y-axis. Now, way back in early elementary school, when you first learned about the number line, you were just looking at the positive side of the x-axis, or the horizontal line here. And then later in elementary school, you started learning about negative numbers and started seeing the number line extend to the left as well. And then eventually, whether it was late elementary or early middle school, you started learning about the vertical or y-axis and having two different sets of numbers put together. To fit in a coordinate plane, you have to have an x value and a y value. Those together are called an ordered pair, like this says here. And the example they give here is the ordered pair 3, -2. The first number is always the x coordinate. That means counting from the origin, you go over 3 spaces. And then the second number here, -2, is always the y coordinate. And from wherever you were on the x, you go up or down. Negative means down, down 2. And that's the point right there, 3, -2, like they indicate here. So the other vocabulary I need to talk about is quadrants. I don't refer to these very often. The textbook occasionally does. Quadrant 1 is the one that you first learned about, the positive quadrant. And then from there, it goes in counterclockwise fashion. Quadrant 2 this way, then quadrant 3, then wrapping around, continuing the counterclockwise. This is quadrant 4's section down here. So if you ever hear the textbook talk about quadrant 2, they're talking about this area of a coordinate plane. And by the way, sometimes I'm going to call it an XY plane, or sometimes just a plane. To plot the point 3, 4, for example, like it says here, start at the origin. Well, there's my origin, 0, 0. And it says move 3 units to the right. I'm going to the right because 3 is positive, and that's a positive 3. 1, 2, 3 spaces. Then over here it says 4 up. I'm going 4 up because it's positive 4, and the second number is the y value, and y either goes up or down. So again, I'm going 1, 2, 3 spaces up, 1, 2, 3, 4, 1, 2, 3 spaces to the right, 1, 2, 3, 4 spaces up, and there's my point 3, 4. Second point I have to plot here is -2, -3. I go to the left 2 because it's -2, and down 3 because it's -3, and there's that point. Lastly, 2, 0. The x value is 2, so from the origin I go over 2. The y is 0. I don't either go up or down. I stay where I am, and that's the point 2, 0. So, based on that, you should be able to make scatter plots of information like this. The second example in the textbook talks about the relationship in some study that was done about height versus weight at some high school and its soccer team. Now, I've drawn an X through this first grid, or this first coordinate plane, because you wouldn't need to use a plane that has the 4 quadrants, because you're never going to have negative height and you're never going to have negative weight. So you're not even going to use these 3 quadrants. You're only going to use this one. And quite often, when we're making graphs, we'll just use the positive quadrant, the first quadrant of the coordinate plane. So I'm going to hit the pause button here, and I'm going to ask you, pull out your own graph paper if you don't have any. Do the best you can to create something that looks like a grid, that looks like a coordinate plane, and plot these points, as it says step A. Once you've done that, do step B, and then step C, and finally step D. When you come back, I'm going to show you the answers. Okay, I'm going to assume that you did that. And this is what the textbook actually came up with for its scatter plot. I want to make sure that I point this out to you. The textbook doesn't even bother to call attention to this. But look, they've actually created what should have been represented as a broken graph. They go straight from the origin to 150, and then after that they count by tens. Similarly here, they go straight from the origin to 66, and then after that they count by ones. So even with textbooks, you've got to stay alert and make sure that you look for graphs that actually are broken, even though they don't say so. So if you had created this as your scatter plot, I've actually just copied the textbooks here, then you would have finished the first task, task A. You've made the scatter plot, and it does have H on the horizontal axis, W or weight on the vertical. By the way, just one quick aside here. Remember, we've talked a lot about the question of independent and dependent variable. Well, I'm not really sure that we can say which one's independent and which one's dependent. Every once in a while you're going to get a relationship between two sets of data where that's not obvious. So the textbook told us to put H on the horizontal, so we did. Now, for B, you were asked to estimate what the weight of a player who's 69 inches tall would be. Well, you've got two different players who are 69 inches tall, but the purpose of a scatter plot, and I know you've done this back in middle school, is to make a best estimate, a best fit line associated with that data. Now that's my line. There is a certain art rather than science to making a best fit line. Oops, I didn't mean to move that, so let me put that back where it was. And one person's line might be slightly different than another's. This is mine. Notice I don't think it's crucial that my line go through any points, and I'm not sure it really does. I would have to move this line. Yeah, there aren't any that are actually under it. That's not the point. It's that it represents the general trend of all of them, and I'll talk about this in class next time we meet. But if I had created this line and I were asked to make a prediction about 69-inch tall and 71-inch tall players, I would plot those two x values, 69 here and 71 here. I would say that a 69-inch tall player would be about 161, 162 pounds. It turns out you actually do have one of those. But then, like I said, you've got another 69-inch tall player who doesn't fit the pattern at all. Similarly, for 71, you don't have anybody that's, whoops, again, I keep moving this and I don't mean to. You don't have anybody that's all that close to your line. So, like I'd said before, there's no guarantee that the actual data will match this best fit line. The best fit line is a general representation of everything. But it does tell you how weight relates to height. And as height goes up, whoops, I keep moving this thing and I don't mean to, I do apologize. As weight goes up, as height goes up, weight goes up as well. So if you had a 74-inch tall player, well, there's 74 inches, I would guess that that 74-inch tall player would be 190 pounds. It turns out there aren't any 74-inch tall kids, so I don't know, but I would say about 190 would be my estimate. Okay. Now, I would like you to make another scatter plot based on this data and just bring this into class, because we're going to work with this when we get to class. So hit the pause button, make that scatter plot for yourself, and bring it with you. Okay, rather than use more video time, I'm going to assume you've hit the pause button and done that, and I'm going to keep going. That's what my scatter plot actually looked like from that data. Notice I ended up making a broken graph in both directions, and I did represent that. So we'll see what you bring in. I'll look forward to seeing that. Moving on, though, to chapter 4.2. If you want to determine whether or not a point, well, why don't you hit the pause button and read this paragraph about example 1, and then I'll talk about it. Okay, I'm going to assume that you did that. If you want to know whether or not the point 1, 2 is on this linear equation, in other words, on this line, well, sure, you could graph that line. In fact, the textbook did that for you here in blue. But you can also do something else, and that's what chapter 4.2 is all about, how to figure out the answer to that question without having the graph. What you would do, you would set up the equation that you have, x plus 3y equals 6, but in place of the x and in place of the y, you'd plug in those x and y values. 1 for x in blue, 2 for y in red. 1 plus 3 times 2, well, 3 times 2 is 6. 1 plus 6 is 7. It's not the same. So therefore 1, 2 is not on the line. And if you did have a copy of the graph, then you could see that for yourself. Here's the point 1, 2, and it's up here. It's just a little above the line, so the answer is no. Now, as it says here, read this again, hit the pause button, read this paragraph, and I'm going to talk quickly about it. Okay, all I want to talk about in this video is what I've highlighted here. So how do you actually graph an equation? Well, one way to do it, and this is where we're going to start with this chapter, is like we've done before, to make a table or list of values and plot enough solutions that you can at least see a pattern, and you can decide if there's a line there or some other shape. So that's what we're going to talk about doing, creating enough values that I can plot enough points from a table that I can see a pattern. Okay, so for example, 3 steps to turning this equation into a graph. First of all, step 1, I've got to rewrite the equation so that it becomes y equals. As it says here, I'm solving for y. So I move the 2 over, and it becomes y equals 3x minus 2. Okay, now I'm done. That was an easy one for step 1. Now, for step 2, I'm going to make a table of values. Well, this is the key point here. In order to make the table, I've got to make up for myself what some values of x are. I would suggest picking easy small numbers to work with. The textbook picks these, and they're perfectly good choices. If you plug each of these x values in, or as it says, substitute rather than plug in, if you plug those into that equation, you'll figure out what y is. Let's move on then to step 3. Step 3 now, I've got coordinates to plot. -2 goes with -8, so the point -2, -8 right there should be on the line. I'm just going to show you one more. 2 for x goes with 4 for y, and the point 2, 4 right there is on the line as well. In fact, you really only need 2 points to draw a line. If you're sure it's a line, then that's all you need. It's just a matter of, are you sure that it's going to be a line? That's the real question. Okay, and that's what this is essentially summarizing in this box in 3 steps. Hit the pause button, make sure you understand these 3 steps, because this is going to become crucial to succeeding with chapter 4.2. Okay, I'm going to assume that you did that. Now, a couple of last things that get you ready for the homework. I want you to do 16, 18, and 20. I'm going to show you 16 and 18 and then have you do 20. So, 16, turning -5x minus 5y equals 15 into a way of answering the question. In place of the x and in place of the y, I've put parentheses, placeholders. I'm going to try -3o in those parentheses. I plug -3 and 0 in there, and sure enough, it does turn out to be 15. Why? Because -5 times -3 is 15. That's 0. 15 plus 0 is 15, so the answer is yes. Like I said, I'll do 18 for you. In this case, I'm rewriting the equation. Instead of x, I'm making parens. Parens are equal to -4. 1 minus 4. Well, my x value is 1. It's not -4. So I plug in 1, and is 1 equal to -4? No. For number 20, I've got this, and the x and the y become parens again. I put in -1, -1, and if you work that out, you'll find it doesn't add up to 7, it actually adds up to 11. Hit the pause button if you're not sure and convince yourself of that. But this turns out to be 11, not 7. So therefore, -1, -1 is not on the line. Last part of this video. 3 more and last problems to do. I'll show you 24 and 26, and I'll have you help me more with 28. Okay, so for 24, x equals 2. Well, if x equals 2, then I know that any point, and it asks me to find 3 different points, I know any point that I have is going to have 2 in for its x coordinate. So I can plug anything I want in for y, and I've picked 3 random points here. Same thing here for 26. If I know y equals -6, I can just put that in ink. I don't have to put it in pencil. And I can put any values I want in for y, and all of those, 1, -6, even 29, -6, are on that line. Last example though, and this is where I want you to hit the pause button and try this. See if you can do 28. Okay, I'm going to assume that you did that. It doesn't give you values for x or y, so you have to try values for x and y. And I just made up easy ones for x, 0, 1, and 2. When you put those in, I found those values for y. And there's your homework.